Alright guys, it is that time again. It's time for another tutorial video. It's a new year and we are headed into our second semester, really in a fantastic position. Today we're going to be talking about finding the missing measures of similar triangles. If you notice here, the problem on the board, on the screen here, says that we are going to be looking at a couple of different measurements, some of which are already put onto the diagram, some of which that we will have to actually recreate on our own. So if you notice there, the problem actually says that the lower cable meets the tree at a height of about 6 feet and extends about 16 feet from the base of the tree. If the triangles are similar, how tall is the tree? So if you notice here at the bottom, this particular tree, this cable that attaches to the top of this tree extends out about 56 feet. What it's telling us is that there's another cable, this cable here, that will attach, and we're not able to really see that here, but it's going to attach to this particular tree in this particular area. And this sticks out 16 feet, okay, from the base of the tree. So the cable will attach here, and then it attaches to the ground, and this is about 16 feet from the base of the tree. So the first thing that I want to do is I want to go ahead and write down some things that we know. I'm going to recreate the triangles so that we can better see what exactly we're looking at. So at this point I want to go ahead and switch over to my drawings page. So first things first, what are some things that I know from the problem? It says that the cable, or a cable, attaches 6 feet above the base of the tree. Okay, and I also know that that cable extends out 16 feet from the base of the tree. So what I want to do is I want to go ahead and draw myself out another triangle. Okay, this is representing our tree, and I won't take it all the way down, but this represents our tree. We know that there is a cable which attaches at about 6 feet above the ground. I'm going to switch over to a pencil so it's better able to see. So this is about 6 feet. And this distance from here to here is about 16 feet. Now I want to stress that this drawing is not to scale, okay? And any drawing, lots of drawings that you get on the STAR, they're not going to be to scale or any other standardized test either. So this distance actually from here to here is going to be about 56 feet. So from here to here, 16, from here to here, 6. So, if you notice, there are two triangles. There is a larger triangle, which I'm going to do an imaginary shading for. Okay, there's this imaginary triangle, this larger one. But within that larger triangle, there's also this smaller triangle, which we want to try to compare it against. Okay, so this smaller triangle in this overall larger triangle. So what I'm going to use is I'm going to use a proportion to help me figure that out. But the first thing that I want to do to make sure that everything is straight is I'm going to go ahead and label all of these points. So there's an imaginary intersection of this line and that line for the height of the tree is, I'm going to say A. We're going to call this point down here B. We're going to call this point C. The point at which the tree attaches to that cable, we're going to call that point D. And the point at which the cable meets the ground, we're going to call that E. So the only thing that we do not know, and I'm going to switch this over, we don't know the height of the tree, and I'm going to call that H. That is our unknown value, okay? So this is our unknown. We do not know the height of that particular tree, okay? And I apologize for my lack of artistic skills. All right. So we want to compare similar or corresponding sides to come up with our proportion. So I'm going to compare CD, that's how you label them. This is this side, of this smaller triangle to the overall side here. Okay? So, that's the comparison. So we're going to do CD, and I'm going to do parts of this triangle to parts of this triangle. Again, this triangle, this side of this triangle to that side. So you'll see what I mean in a moment. So I want to compare CD, which is this part, okay, to this longer part of the smaller triangle. I'm going to set that as equal to, again, the side that I'm looking for, which is the unknown side of this particular tree. We're going to call this AC, and the way that I label these is they label in alpha order. Okay, so that's why I'm doing it that way. To this side. Okay, so again, I'm comparing this height to this long side of the smaller triangle, this larger height to the longer side of the larger triangle. So again, we're doing height of the smaller triangle to the height of the tree. We're doing the longer side of the smaller triangle to the longer side of the larger triangle. Okay? So now I'm going to rephrase this actually with numbers at this point. This is 6 feet over 16 feet. So height to shadow cast, or the point at which that cable will attach to the tree, it goes out 16 feet. I then am going to put this, my unknown is the AC value. Again, remember that's my unknown, that's the height, that's why I put H. Then I'm going to put 56 feet as the overall length from the top of the tree to this cable here. Now why they would attach a cable to the top of the tree, I don't know. But that's what it's actually mimicking. So at this point, what I want to do is I want to go ahead and set up a simple equation where if I cross multiply both of these, it's going to give me certain values. This is 16H, and for now I'm leaving the units behind. 16 times H, that's my unknown. I'm going to do 56 times 6. I'm going to restate this again as 16H is equal to 336, because what I've done is I've multiplied these two. Multiplied, set them as equal to each other. It's going to give me a value of H. Once I actually divide both sides by 16, I'm just using the inverse operation. We all know how a simple equation works. Once I do that, it comes out to be 21. That's going to be 21 feet. So we're estimating that the height of this tree, because these are similar, okay, because these are similar, we will come up with 21 feet by using a simple equation. And that is pretty much it, you guys, using those similar triangles. As always, if you have any questions, you may rewatch this video. You can always ask me in class for clarification or stop by one of my tutorials twice a week. And as always, I'll see you tomorrow.